Hi, and thank you for tuning in to Gavin Lon Digital. I'm Gavin Lon. So, at this point in the course, we are creating our database infrastructure. We have now covered building the infrastructure for our identity database tables, which provide storage for the membership aspect of our application. For more details on the identity system and associated database tables, please view parts 3, 4, and 5 of this course. Links to these videos can be accessed below in the description. So in this video, we are going to build the infrastructure for what I have labeled our custom tables. Note that I've labeled these tables custom tables in order to differentiate these tables from the identity tables. We are going to use Entity Framework Core code-first data migrations to create our custom tables. For content like this and much more, please consider subscribing and please hit the bell icon to be notified of future content. If you like this video, please give it a thumbs up. It will be greatly appreciated. So, these custom tables that we are going to create are the category table, the category item table, the content table, the media type table, and the user category table. So we know that MVC stands for Model View Controller. In this video, we are going to create the models that represent the custom tables in our application. Just to remind ourselves what is meant by models. The model classes represent domain-specific data and business logic in the MVC application. It represents the shape of the data as public properties and business logic as methods. So, the models in an MVC application are simply represented as C# classes in our code. So, we are going to create a class for representing the category table, a class for representing the category item table, a class for representing the content table, a class for representing the media type table, and a class for representing the user category table. This is why this process is referred to as code-first data migrations. We first create the classes that represent our data entities. We then get EF Core to automatically generate the migration code by running the add-migration Entity Framework Core command. The migration code is generated based on relevant code changes. If we are happy with the migration code that has been generated by EF Core, through running the add-migration command, we can commit the changes to our database defined within the relevant migration. So let's get started by creating a folder in our project to house our models. Let's name this folder Entities. I feel this is a good name for a folder that contains the models we are about to create because the database table entities will be created from the classes we will store in the Entities folder. So let's create the first class in our Entities folder. And let's name it Category. So this is our first model. So each field in the category entity will be represented by a public property. So let's create an auto-implemented public property of type int named ID. Note that Entity Framework will automatically create a primary key column for the property named ID. Or we could have also named the property with an entity class name prefix followed by the literal text ID. And this would be case insensitive. So note that this is a convention in Entity Framework. An integer public property that is named ID will automatically be interpreted as the primary key. Let's create the next property, which represents a field named Title. This property is of type string. We want the corresponding field in the category database table to not allow nulls. So let's decorate this property with the required attribute. The required attribute will also generate code for ensuring that the user enters a value for the title field in the corresponding view. The validation-related attributes will be discussed in detail when we discuss views in this course. In this video, we are only focusing on the model aspect of the application. In order to use these attributes, we must include a using directive to the system.componentModel.dataAnnotations namespace. We want the title field in the category database table to never have less than 2 characters and be restricted to a maximum character length of 200. So this can be implemented using the string length attribute like this. So you'll see later that by declaring the title property to be restricted to a maximum of 200 characters through the string length attribute, that this will result in restricting the title field's associated nvarchar data type to 200 characters. The next property is of type string and is named description. We don't need to decorate this property with any attributes because we want this field to allow nulls and we don't want it to have any character length restrictions. The next property is named thumbnail image path. The corresponding field in the database will store a relative path to an image that an administrator can choose to represent the relevant category. So, for example, the advanced C# category could be represented by this thumbnail image. Please see the first part of this course for more clarity on this field. So let's decorate this field with the required attribute, which means that the corresponding field in the relevant database table will not allow nulls. You'll see later on in this course that the declaration of this attribute will also enforce a rule whereby a user must enter a value for this field on the front end. The front-end validation aspect of this application will be discussed in detail when we focus on views later on in this course. Great, so let's leave this model or class for now. We'll come back to this class a little bit later. Let's create the category item class. We know from the third part of this course that the category entity has a one-to-many relationship with the category item entity. Let's create the ID property that represents the primary key column in the corresponding category item database table. Let's create the title property and let's include the relevant attributes for the title property. Let's include the category ID property. Note that this property represents the foreign key field from the category entity. We'll look at how we can declaratively enforce referential integrity between the category entity and the category item entity a bit later in this tutorial. Let's include the media type ID integer property. This property represents the foreign key field from the media type entity. We'll create the model representing this entity in a bit. Let's include a property named DateTimeItemReleased, and this property must be of type DateTime. So in order to represent the referential integrity between the category table and the category item table, we need to modify our category class. Note that the category item class includes the category ID property, which represents the foreign key field from the category entity. So we must let Entity Framework Core know, as it were, that we want to enforce referential integrity between the category entity and the category item entity. Remember, there is a one-to-many relationship between the category entity and the category item entity. Please view the first and third parts of this course for more detail. So let's go to the category class and include a property of type iCollection that is strongly typed with the category item user-defined type. We can then declare this property with the foreign key attribute, like this. So note that in order to use the foreign key attribute like this, we need to include a using directive to the system.componentModel.dataAnnotations.schema namespace. So you can see that we are passing a string value, which in this case is the text category ID, to the foreign key attribute constructor. This declaratively establishes the referential integrity between the category and the category item entities. As you know, the category item class contains a property named category ID. So by passing the text category ID to the foreign key attribute, we are declaratively establishing the appropriate relationship between the category entity and the category item entity. So we have now defined the referential integrity between the category and the category item entities at the code level. Let's create the next model, which is represented by a class named MediaType. let's include an ID property to represent the primary key field. Let's include a title property and decorate the title property with the appropriate attributes. Let's include a string property named thumbnail image path and decorate it with the required attribute. This field will store the relative path to an image representing the media type of the relevant content. For example, an item of content could contain a video, whereby the thumbnail image might be a video icon. Please see the first part of this course for more details on this. So note that in the category item class, we have included a property named media type ID. This is a foreign key field from the media type entity. The media type entity has a one-to-many relationship with the category item entity. We need to establish the appropriate referential integrity between the media type entity and the category item entity. We can do this by including the appropriate property in the media type class and decorating the appropriate property with the foreign key attribute in the media type class. So to do this, let's create a property of type iCollection that is strongly typed as category item, and let's name this property category items. We can then decorate this property with the foreign key attribute like this. So you can see that we are passing a string value, which in this case is the literal text media type ID, to the foreign key attributes constructor. This tells Entity Framework Core, as it were, that the media type ID property represents a foreign key from the media type class. So we are demonstrating the same principle that has already been demonstrated when we declaratively established the referential integrity between the category entity and the category item entity. So let's create a class named userCategory. Let's create an ID property to represent the primary key field. Let's create a user ID property of type string. And let's create a property named category ID, which is of type integer. The userCategory entity is a join entity that enables the category entity to have a many-to-many relationship with the ASP.NET Users entity. So the ASP.NET Users table maps directly to the application user class that we have already created. So the ASP.NET Users entity is an identity table that already exists in our database, and it maps directly to the application user class, which we have created to extend the EF Core identity user class. So the userCategory entity has a many-to-one relationship with the category entity. So let's go to the category class and establish the appropriate referential integrity between the category entity and the userCategory entity. So to do this, let's add a property named userCategory to the category class. The property is of type iCollection and is strongly typed with the userCategory user-defined type. So to establish the appropriate referential integrity, we need to decorate the userCategory property with the foreign key attribute and pass in the appropriate property name that is a member of the userCategory class to the foreign key attributes constructor. This property is the foreign key field and is named category ID. So let's pass in category ID as literal text to the foreign key attribute. The userCategory entity has a many-to-one relationship with the ASP.NET Users entity, which as discussed maps directly to the application user class. So let's go to the application user class, which is in the application.db.context.cs file, and establish the appropriate referential integrity between the userCategory entity and the application user entity. The reason for including the virtual keyword here in this property definition will be explained in a later tutorial. And just to emphasize, the application user class corresponds to the ASP.NET Users identity table that we created in the fourth part of this course. Note that the user ID field in the user category class, which is a foreign key from the ASP.NET users entity, is of type string. This is because the ID primary key field in the ASP.NET users table stores GUIDs to represent its primary key values. Please see the third part of this course for more information on GUIDs. So the last entity to create is the content entity. So let's create a class named content. Let's add the property that represents the primary key to this class. Let's add a string property named title. Let's say this is a required field and should never have a character length less than 2 characters or a character length greater than 200 characters. Let's add a string property named HTML content. Let's add a string property named video link. So the content entity has a one-to-one relationship with the category item entity. So let's establish the appropriate referential integrity between the content entity and the category item entity. We are able to declaratively establish the referential integrity between the content entity and the category item entity with this code. So you can see that establishing the referential integrity for entities that have a one-to-one relationship between them is slightly different to establishing referential integrity between two entities that have a one-to-many relationship. And it is as simple as that. We have created the code which serves as the basis for a migration that can be run to create our custom tables in our database. But there is one more very important step. We need to tell Entity Framework Core about the models we wish to use as templates for generating our custom tables in our database. So, to do this, we first need to go to the application.db.context.cs file. Within our application.db.context class, we need to let Entity Framework Core know, as it were, about our new models in order for Entity Framework Core to be able to generate the appropriate migration code to create the corresponding database tables in our database. So we are going to create 5 properties, each of type dbSet, within the application.db.context class. Each property represents a table we wish to create within our database. So the tables I'm referring to are our custom tables: category, category item, content, media type, and user category. So let's create a public auto-implemented property of type dbSet that is strongly typed as the category class in the application.db.context class. Note that you must include a directive to the tech-tree web application.entities namespace, which is where the relevant model classes reside. Let's include the other properties of type dbSet in our application.db.context class. Notice how each property typed as dbSet is strongly typed with the appropriate user-defined type, i.e. the user-defined types that denote our custom tables: category, category item, media type, user category, and content. And that is it. We are now ready to create our migration code. So let's invoke the Package Manager console window. Let's type in add-migration, and then let's include a name for our migration. Let's name this migration Add Custom Tables. Let's press the Enter key. And there it is, our migration class named Add Custom Tables. So there's one thing that I wish to tweak here in our migration code. So for example, if a particular user is deleted for the ASP.NET users table, I want all related rows in the user category table to be automatically deleted. So in order for this cascade effect to happen, we must ensure that the referential action.cascade constant rather than the referential action.restrict constant is passed as an argument to the onDelete parameter to this method. Further to this, we know that the category entity has a one-to-many relationship with the category item entity. and the category item entity has a one-to-one relationship with the content entity. When a category is deleted by the administrator, I want its associated category items deleted, as well as each category item's associated content deleted automatically. So for example, if the advanced C# category is deleted by an administrator, we also want, for example, the introduction category item, the delegates category item, and the generics category item to be deleted automatically. So we want all associated category items deleted when a category is deleted. We also want the content related to the category items automatically deleted. So if you see here in the migration code, we have the foreign key method used to establish the appropriate referential integrity between the relevant entities in our database. We need to pass the constant represented as referential action.cascade as an argument to a parameter named onDelete here. This functionality was automatically included for the category item entity, but has not been included automatically for the content entity. So let's modify this code in our migration so that when a category is deleted, its associated category items will also be deleted, as well as the content associated with each relevant category item. So we can achieve this by modifying our migration code here by changing the referential action.restrict constant to the referential action.cascade constant, like this. Right, so we can now run the update-database command to commit the changes denoted in our migration named add custom tables to our database. Before we commit the changes to the database by running the update-database command, I want to point out that two methods are created in each of our migrations. So when we automatically generate a migration, there are always two methods. We have one method named up and the other method named down. These methods are very easily understood. The method named up contains the code to update the database with the changes that have been made to the model classes in our code. The code in the relevant down method contains code to undo the database changes denoted by the code in the relevant up method. So when a migration is rolled back, the code in the relevant down method is run to undo the changes that are denoted by the code in the relevant up method. For more information on rolling back database changes using the update-database command, please view the previous part of this course, i.e. the 5th part of this course. All links mentioned in this video are included below in the description. So let's type in the update-database command in the Package Manager console window. And let's press the Enter key. Great! Let's look at our database in SSMS or SQL Server Management Studio. Excellent! We have now built a foundation for our web application. If we look at this diagram, this is what is now manifested in our database through the implementation of Entity Framework Core data migrations. Excellent! To help clarify your understanding of code-first data migrations, please see links that I have included below in the description under the section marked Additional Information about EF Core Code-First Data Migrations. If you like this video, please give it a thumbs up. Please consider subscribing for content like this and much more, and please ring the bell to be notified of future content. Please feel free to share this video with anyone you feel may benefit from its content. I really enjoy engaging with you in the comments section, so please feel free to share your thoughts with me in the comments section. The latest code can be found on GitHub. A link to the relevant repository has been included below in the description. Thank you, and take care.